Welcome back to the Deep Dive. Today we are really zeroing in on a piece of hardware that is just absolutely critical for data center uptime.
Right.
The NTI E-SLDO-14 compact size spot liquid detector. Our mission is to look beyond the spec sheet and really distill the engineering philosophy behind it.
Well, and what's so fascinating here is the context. A liquid detector, it sounds so mundane, doesn't it?
Yeah, totally.
But in these mission-critical environments, they're the frontline defense. We're talking about those forgotten corners, like underneath big AC units or tucked into condensation drip pans.
Places where anything can go wrong.
Exactly, places where humidity and heat are just begging to kill standard electronics. So for you, the learner, knowing these specific design details is really key to understanding infrastructure resilience.
Absolutely. So the device we're dissecting is the E-SLDO-14. It's currently priced at $155, and it includes a 2-year NTI warranty.
Which, for what it does, is a pretty interesting price point.
It is. Considering this is a relatively low-cost item, you have to ask, where did NTI spend the engineering budget to justify its role in these systems? It seems to start with the physical constraint.
It has to. It's got to be small to fit in those tight spots. It's, what, 1.55 by 1.0 by 2.0 inches? Super compact.
Tiny.
But, the size isn't the primary engineering achievement here. The defining choice is durability. It's designed specifically to prevent failure when you need it most.
And here's where it gets really interesting. They achieve that durability through two core features. The first one is potted electronics. What does that even mean in practical terms?
It means the circuit board is completely sealed. It's encased in this solid compound. So the sensor, it doesn't just survive a spill.
Right.
It's designed to function even when it's completely submerged in water. It ensures the failure mode is predictable and, external, not some random internal short.
That sounds almost invincible. But I wonder about serviceability. If this thing fails, it's completely unrepairable, right? You crash the whole unit.
You do. Exactly. It's a trade-off. Maximum reliability for zero serviceability. But the second key detail really answers why this is so necessary.
Okay.
They eliminated exposed metal sensing posts. I mean, think about those cheap sensors you leave in a humid drip pan for a year.
They just corrode. They turn into a pile of green-blue dust.
A pile of corrosion, yeah. No metal posts means there's literally nothing to rust or corrode over time. It guarantees long-term function.
That anticipates the environment perfectly. And they've even given the installer some flexibility. The probe height is adjustable from 0 up to 0.75 inches.
So you can customize that detection threshold.
Yeah.
Super early warning.
Right.
And of course, once this tough little sensor detects fluid, it needs to talk to the system. It uses SPDT alarm contacts and has one generic relay output.
For anyone who doesn't know, what's SPDT?
It's basically a smart switch. When water hits it, it can signal two things at once. It could say, trigger the main monitoring system alarm and shut down the adjacent HVAC unit.
Ah, so that's the real system integration point.
That's it.
And we should probably touch on compliance. I mean, it's not enough that it just works. It has to be compliant for these big projects. We see CE, OOHS, and TAA compliant is on there too.
And the TAA is crucial. It stands for the Trade Agreements Act. That's essential for, major federal or commercial data center projects. It ensures the device meets U.S. procurement standards.
It's part of the trust equation, though.
Totally. Plus, they anticipate global deployment. The standard version has a U.S. power supply, but there's a slightly pricier version at $180 that handles other voltages. They even offer an IP68 fully submersible detector. So this level of robustness is kind of their baseline.
So let's tie this all back for the learner. Understanding these specific features, the potted electronics, the non-corroding parts, it shows that effective monitoring relies entirely on engineers anticipating the harsh, wet, unforgiving reality of where this sensor is going to live.
They basically designed failure out of the product. And this really raises an important question for you to think about. If a device this small requires such robust, specific engineering just to reliably detect a little bit of water, what complex system challenges are we overlooking in the everyday world all around us?
It's a great question. Makes you think about all the engineering required for true reliability in those confined, unforgiving spaces we never even see.